Now that we have a better understanding of angles on a straight line, vertically opposite angles, corresponding angles, alternative angles, and co-interior angles, let's look at some examples of how we work with them. Use the information in the diagram below to find the unknown values. Here we need to find the values of A, B, C, D, and E. But you don't need to find the letters in alphabetical order. The only angle we've been given is 140 degrees. So let's mark this in purple. Always start with the information you've been given. The arrows show us that line AB is parallel to line CD. 140 degrees lies between the parallel lines, but below line AB. So let's start by looking for corresponding angles. Let's draw in our F shape. Both the 140 degree angle and angle 5B lie below the parallel lines to the right of the transversal line, which means that these are corresponding angles and they are equal. So let's mark angle 5B in purple as well. Now we can make our statements and give our reasons. We know that 5B is equal to 140 degrees because corresponding angles are equal. So as our reason, we say corresponding angles. Remember that the reason why corresponding angles are equal is because AB is parallel to CD. And we have to include this in our reason as well. Now, 5B is equal to 140 degrees. So let's find the value of B. If 5B is equal to 140 degrees, then B must be equal to 140 degrees over 5. So now we can get our calculator and we say 140 divided by 5 is equal to 28 degrees. This is the value of B. Now let's take out our red F. B is 28 degrees, but our angle is 5B. It is the corresponding angle of 140 degrees. So 5B must be 140 degrees as well. So let's take 5B out of the diagram and we can fill in 140 degrees. Now down here we can see the transversal line EF, let's make it red, crosses the line CD. So let's make this part red as well. Angle A lies vertically opposite the 140 degree angle. So let's make angle A purple. We know from our previous video that vertically opposite angles are equal. So A must also be 140 degrees. So let's make our statement up here. The reason why A is 140 degrees is because they are vertically opposite angles. Now we can take out our red lines. Let's take out A and we can replace it with 140 degrees. Next, let's look at angle C up here. It lies on a straight line along with an angle of 140 degrees. We know the sum of the angles on a straight line is equal to 180 degrees. So 140 plus C is equal to 180 degrees. As our reason, we write angles on a straight line. Now we can use this to find the value of C. If 140 degrees plus C is equal to 180, then C is equal to 180 minus 140 degrees. 180 minus 140 gives us 40. So C is 40 degrees. On our diagram, let's take C out, write in 40 degrees, and make this angle green. Now the transversal line EF, let's make this part red, crosses the line AB. Let's make this part red as well. From this, we can see that angle 2E lies vertically opposite angle C, which we found to be 40 degrees. We know that vertically opposite angles are equal, which means that 2E is equal to 40 degrees because they're vertically opposite angles. Now, if 2E is 40 degrees, then to find the value of E, let's divide by 2, and we see that E is equal to 20 degrees. Now, E is 20 degrees, but the angle is 2E, which is 40 degrees. So let's take out our red lines, take out 2E. Let's write in 40 degrees, and we can make this angle green as well. Now we need to find the last letter, D. D lies to the right of the transversal line above CD. Now we've just found a 40-degree angle that also lies to the right of the transversal line above AB, this angle over here. So let's draw our F in red once again. Both angles lie to the right of the transversal line above the parallel lines. So these are corresponding angles. And we know that corresponding angles are equal. So we know that D is equal to 40 degrees because these are corresponding angles. Now we found the sizes of all of the unknown angles in the diagram, and we've completed this question. Let's do another example. Use the information in the diagram below to find the unknown values. Here we've been given an angle of 42 degrees, and we need to find F, G, H, I, J, K, and L. For every statement we make, we need to give a reason. Now, from the diagram, we can see that AB is parallel to CD, so we can consider corresponding angles, alternative angles, and co-interior angles. So up here, let's make a note that AB is parallel to CD. Now let's look at our given angle of 42 degrees. Let's make it red. Straight away, we can see the transversal line EF. Let's mark the section in purple. Crosses the line AB. So let's make the section purple as well. Angle G lies vertically opposite the 42-degree angle. We know that vertically opposite angles are equal. So we can make a statement that G is equal to 42 degrees because these are vertically opposite angles. Now we can take our purple lines away. Let's take G out of the diagram. We can write in 42 degrees and we can make this angle red. This angle lies to the left of the transversal line below AB. So let's draw in our big F. We can now see that angle L down here also lies to the left of the transversal line, but below CD. So these are corresponding angles. We know that corresponding angles are equal. So we can say that L is equal to 42 degrees because these are corresponding angles. Let's take our purple F out, take out L. We can write in 42 degrees and make this angle red as well. Now, this angle of 42 degrees lies between the parallel lines AB and CD. So let's see what other angles lie between these parallel lines. Let's look for alternative angles. So let's draw our Z shape in purple. Now, straight away, we can see that this 42-degree angle and angle J both sit inside the Z shape. So these are alternative angles, and we know that alternative angles are equal. So J is equal to 42 degrees because these are alternative angles. Now we can take out our Z shape. Let's take out J. Let's put in 42 degrees and make this angle red as well. Before we carry on, there are two important things you need to keep in mind. First of all, don't be scared to draw on your diagrams. Make notes, write down the angles you found, mark equal angles in the same color. This will help you to find unknown values. Also, more importantly, the reason you give can differ depending on the angle you relate your answer to. Here, we've just found that J is 42 degrees. And we said that J is 42 because it is an alternative angle to this angle over here. But J is also a corresponding angle to this angle up here. And it is the vertically opposite angle to this angle down here. So you can use any of these reasons to justify the angle of J. All three will be correct. Let's tidy this up. And now we can look at angle H. Both H and J lie to the right of the transversal line and between the parallel lines. So let's draw our F in purple. 42 degrees and H sit between the horizontal lines of F. So these are co-interior angles. We know that co-interior angles are supplementary, which means they add up to 180 degrees. If these two angles add up to 180 degrees, then to find H, we can say H is equal to 180 minus 42 degrees, because both of these are co-interior angles that are supplementary. Now let's find H. Let's take our calculator and we say 180 minus 42, and we get 138. This is the size of angle H. Now let's take out our purple F. Let's take H out. Let's fill in 138 degrees. We can make our angle green. Angle F lies vertically opposite the angle we've just found, which means that F is also equal to 138 degrees because these are vertically opposite angles. Let's take F out of the diagram. Let's write in 138 degrees and make this angle green as well. This angle lies to the left of the transversal line above AB. So let's draw our big F back in. We can see that this angle and I lie to the left of the transversal lines and above the parallel lines. So these are corresponding angles, so they are equal. So now we can say I is equal to 138 degrees because these are corresponding angles. Now we can take out our F. Let's take out I. Let's write in 138 degrees and we make our angle green. Finally, let's find K. K lies vertically opposite this 138 degree angle. We know that vertically opposite angles are equal. So we can say K is equal to 138 degrees because these are vertically opposite angles. And now we've completed this question. Let's do one more example that's a little more difficult. Use the information in the diagram below to find the unknown values. Here, we need to find the values of M, N, P, Q, and R. The arrows on line ST and line UV show that these two lines are parallel. So let's highlight them in blue. To find angle relationships, you need to use parallel lines and a transversal line. So let's highlight the transversal line TU in purple. Now we can make our statements and give our reasons. The 50-degree angle over here lies between the parallel lines to the left of the transversal line. So let's draw in our Z shape. Now this angle of 50 degrees and angle M both sit inside the Z shape, so they are alternative angles. We know that alternative angles are equal, so we can say M is equal to 50 degrees because these are alternative angles. Remember that corresponding angles, alternative angles, and co-interior angles only occur when we have parallel lines. So these are alternative angles because ST is parallel to UV. Now we can take out our Z shape. Let's make our angle green. Take out M and fill in 50 degrees. Now we know that this red square over here shows us that angle U is 90 degrees. We know this because this has been given to us in the diagram. So we use given as our reason. Now we can see that the 90-degree angle, the 50-degree angle we've just found, and N all sit on the same straight line. We know that angles on a straight line give us the sum of 180 degrees, and we can use this to find the value of N. So we can say 180 degrees minus the 90-degree angle minus the 50-degree angle we just found is equal to the value of N. 180 minus 90 gives us 90, minus 50 gives us 40 degrees. So N must be 40 degrees because these are angles on a straight line. Let's make angle N orange. Now we can take N out and write in the angle of 40 degrees. Now, TU is not the only transversal line we have to work with. So let's make TU black again. WX also cuts both of our parallel lines. So this is also a transversal line. Let's make WX purple. We have three angles sitting to the left of WX. 140 degrees, angle R, and angle P. So let's draw in our F shape. Now we can see that both the 140-degree angle and P sit on the left of the transversal line, but below the parallel lines. These are corresponding angles, so they're equal. This means that P is equal to 140 degrees because these are corresponding angles. We know that these are corresponding angles because line ST is parallel to UV. Now we can take the red F out. Let's also make our 140-degree angle yellow. P is also 140 degrees. So let's make this angle yellow as well. Now we can take out P and write in 140 degrees. Now we know that P is 140 degrees, and we can see that we found N to be 40 degrees as well. 140 plus 40 gives us 180 degrees. So let's make a note of this over here. These angles lie between WX and the line UY. So let's make UY purple as well. We know that if two lines are parallel, then the angles that lie between them on the same side of the transversal line are co-interior angles that are supplementary because they add up to 180 degrees. The only way that two co-interior angles are supplementary is because the two lines they lie between are parallel. But in our previous videos, we learned about theorems and converse theorems. We said that if two lines are parallel, then co-interior angles are supplementary. But if we can find two co-interior angles that add up to 180 degrees, then the lines they lie between must be parallel. Here, 140 degrees plus 40 degrees gives us a sum of 180 degrees. These angles are supplementary. They lie between WX and UY, which means the only way that this is possible is because WX has to be parallel to UY. We have now proven this, so we can make the statement that WX is parallel to UY because co-interior angles are supplementary. To show that these lines are parallel on our diagram, let's put two arrows on line WX and 2 on line UY. Now that we have two new parallel lines, it means that VU is also a transversal line because it cuts both WX and UY. We need to find the value of R. So let's draw in our big Z shape. Straight away, we can see that R and this 40-degree angle over here both sit inside the Z shape. So they are alternative angles. And we can say that R is equal to 40 degrees because alternative angles are equal. And the reason why these alternative angles are equal is because WX is parallel to UY. Now we can take out our Z shape. Let's make our angle orange. Then we can take out R and write down 40 degrees. Finally, let's find the value of Q. WX, let's make the section red, crosses VU. So let's make this section red as well. Now we can see that Q lies vertically opposite to angle R, which we just found to be 40 degrees. Vertically opposite angles are equal, so we can say that Q is equal to 40 degrees because these are vertically opposite angles. Now we found the values of M, N, P, Q, and R. So we have now finished this question.